Welcome to Mass Production Marvels, where we explore the incredible world of automated manufacturing and the precision of modern engineering systems. Our journey begins with raw silica sand, the foundational element that will eventually become the brain of our advanced electronic devices. Inside a massive industrial furnace, extreme heat purifies the raw silicon, transforming it into an ultra-pure liquid state for processing. A single crystal seed is slowly withdrawn from the molten silicon, growing into a massive, flawless cylindrical ingot over several days. High-precision diamond wire saws slice the heavy silicon ingot into incredibly thin wafers, measuring less than a single millimeter thick. Each delicate wafer undergoes intense mechanical polishing, achieving a perfectly reflective, mirror-like surface completely free of any microscopic surface scratches. The pristine wafers are carefully loaded into automated cleaning chambers, where specialized chemical baths remove every trace of dust particles. Next, a thin layer of photoresist chemical is evenly spun across the wafer surface, preparing it for the lithography process. Advanced extreme ultraviolet lithography machines project highly intricate circuit patterns onto the light-sensitive wafer with absolute nanometer-scale precision and accuracy. Chemical solvents wash away the exposed photoresist, leaving behind a perfect protective mask that outlines the future microchip circuitry design. An acidic etching gas carves away the unprotected silicon areas, permanently engraving the microscopic pathways into the wafer's crystalline structure. High-energy ion implanters shoot dopant atoms directly into the silicon, modifying its electrical conductivity to create millions of tiny transistors. Ultra-thin copper layers are electroplated onto the wafer, filling the microscopic trenches to connect the newly formed transistors perfectly together. A chemical-mechanical planarization machine grinds down the excess metal, ensuring the wafer surface is perfectly flat for the next layer. This complex cycle of deposition, lithography, and etching repeats dozens of times, building a highly complex three-dimensional network of microscopic circuits. Automated optical inspection systems scan the completed wafer, identifying any potential microscopic defects before the individual chips are finally separated. A precision dicing saw cuts along the grid lines, separating the giant wafer into thousands of individual microchip dies. Robotic vacuum nozzles pick up each working die and place it onto a protective substrate, starting the crucial packaging process. Ultra-fine gold wires are carefully bonded between the chip pads and the lead frame, establishing the vital electrical connections required. A black epoxy resin is molded around the fragile silicon die, encapsulating and protecting it from physical and environmental damage. Laser engraving systems mark the model number and unique tracking codes onto the hard plastic surface of each completed microchip. We now transition to the production of the printed circuit board, which serves as the physical backbone of the device. Large sheets of fiberglass resin are laminated with thin copper foil, creating the raw base material for our circuit boards. Computer-controlled drills pierce thousands of tiny holes through the multi-layered board, allowing electrical signals to travel between various different layers. The boards pass through an electroplating bath, coating the inside of the drilled holes with copper to establish electrical conductivity. A green liquid solder mask is applied to the entire board, protecting the copper traces from corrosion and accidental bridging. A white silkscreen layer is printed onto the board, labeling component locations and providing essential guide markers for assembly robots. The completed circuit boards are cut into individual units using a high-precision automated router that ensures perfectly smooth outer edges. Solder paste is precisely applied to the board surface through a laser-cut metal stencil, targeting only the component connection pads. High-speed pick-and-place machines use vacuum nozzles to place tiny surface-mount components onto the wet solder paste with incredible speed and accuracy. The populated boards enter a multi-zone reflow oven, where controlled heat melts the solder paste, forming permanent solid electrical connections. An automated optical inspection system scans the soldered boards, verifying component alignment and identifying any potential critical soldering defects instantly. A protective conformal coating is sprayed over the circuit board, shielding the sensitive components from moisture, dust, and harmful vibration. Now, we explore the fabrication of the metal casing, which starts with raw solid blocks of high-grade aerospace aluminum alloy. A powerful computer numerical control milling machine carves the outer profile of the device chassis with extreme speed and precision. The robotic milling tool head switches automatically to carve out internal compartments for the various battery, motherboard, and speaker modules. High-pressure water jets mixed with abrasive garnet particles cut precise openings for the charging port and other essential physical buttons. The aluminum chassis is submerged in an anodizing bath, creating a durable, corrosion-resistant oxide layer on its outer metallic surface. Electrochemical dyes are introduced to color the anodized aluminum, giving the raw device casing a beautiful, vibrant, premium metallic finish. An automated laser etching machine engraves the brand logo and regulatory symbols onto the back cover with perfect visual alignment. We now focus on the display production, starting with large sheets of ultra-thin, chemically strengthened aluminosilicate protective outer cover glass. A high-precision laser cutter slices the glass sheets into individual display panels, ensuring perfectly clean edges without any unwanted microcracks. The glass panels undergo a chemical tempering bath of molten potassium salt now, significantly increasing their overall structural impact resistance. An oleophobic coating is applied via vacuum deposition, preventing fingerprint smudges and making the screen extremely easy to clean always. In a cleanroom environment, high-resolution OLED panels are laminated onto the protective glass using highly specialized, optically clear liquid adhesive. A robotic arm applies a flexible printed circuit connector to the display panel, enabling direct communication with the main motherboard. We now enter the final assembly stage, where all the individual components are brought together on a synchronized production line. Robotic arms apply precise lines of liquid adhesive along the inner edges of the aluminum chassis for future excellent waterproofing. The main motherboard is carefully lowered into the aluminum chassis, aligning perfectly with the pre-milled mounting standoffs inside the device. Miniature pneumatic screwdrivers secure the main motherboard with tiny, highly precise screws, ensuring it remains firmly in place there always. The high-capacity lithium-ion battery is placed into its dedicated compartment, secured with strong, double-sided pull-tab adhesive tape inside the chassis. Robotic arms carefully connect the delicate battery ribbon cable to the main motherboard, completing the power distribution circuit successfully now. The front-facing camera module is carefully inserted into its alignment slot, designed to capture sharp, high-resolution photos and videos always. Next, the advanced rear camera array is carefully positioned, containing multiple lenses for optical zoom and professional wide-angle photography now. A specialized electromagnetic shield is carefully placed over the processor, preventing radio frequency interference from affecting other sensitive components inside. Copper heat pipes are carefully installed across the battery and CPU, designed to efficiently dissipate heat during heavy gaming sessions. The speaker module and haptic feedback motor are pressed into place, wired to deliver rich sound and realistic tactile vibrations. Antenna bands are carefully routed along the inner frame, ensuring strong cellular and wireless connections for the ultimate end user. The display assembly is carefully connected to the motherboard, completing the final electrical loop before the casing is finally closed. A robotic press pushes down with consistent force, sealing the display assembly to the aluminum frame with strong waterproof adhesive. The newly assembled devices move along the conveyor belt to the testing station, where automated software flashing begins here immediately. Pogo pin connectors touch the motherboard pads, rapidly uploading the operating system and essential firmware in just a few seconds. The device boots up for the first time, displaying a beautifully bright screen as the automated calibration sequence commences now. High-resolution cameras inspect the screen, analyzing color balance and brightness uniformity to ensure a completely flawless visual display experience always. Automated robotic fingers tap across the touchscreen, verifying response times and detecting any potential dead zones on it instantly. The device is placed inside a specialized anechoic chamber, where automated antennas measure wireless signal strength and connection quality accurately. Ultra-sensitive microphones test the internal speaker volume and clarity, ensuring the audio output meets strict industrial quality standards here always. A robotic actuator plugs a cable into the charging port, verifying fast charging capabilities and overall battery health status instantly. To test waterproofing, the completed devices are placed inside a specialized pressure chamber that simulates deep water submersion environments safely. A mechanical arm drops the device repeatedly onto a solid steel plate, ensuring the chassis can survive daily drops easily. A climate chamber subjects the device to extreme temperatures, verifying it operates perfectly in both freezing and hot climate conditions. A specialized machine bends the device with controlled force, testing the structural integrity of the aluminum frame under bending pressure. The device screen is rubbed repeatedly with abrasive materials, verifying the scratch resistance of the tempered protective cover glass surface. Robotic arms repeatedly press the physical buttons thousands of times, ensuring they maintain a tactile, clicky feel over many years. Now, the devices pass through a final automated cleaning station, where high-pressure clean air removes any remaining dust particles efficiently. A protective plastic film is automatically applied to the screen, protecting it from scratches during shipping and final handling here. We now transition to the packaging line, where flat cardboard sheets are automatically folded into the final retail box structure. A high-precision printer prints the device specifications and barcode serial numbers directly onto the bottom of each retail box now. The user manual and warranty booklets are carefully placed into the box, followed by the USB-C charging cable accessory inside. A robotic arm picks up the completed device and gently places it into its designated tray inside the packaging box. The retail box lid is automatically lowered, completing the packaging structure as it moves quickly towards the shrink wrap machine now. A thin plastic film is wrapped around the retail box, and a heat tunnel shrinks it to a tight, perfect seal. The completed shrink-wrapped boxes are grouped into clusters of 10, preparing them for bulk packaging in larger shipping cartons now. A robotic gantry system carefully places the grouped boxes into a heavy-duty cardboard shipping carton with perfect spatial efficiency always. An automated tape dispenser securely seals the top and bottom of the shipping carton, securing the valuable contents inside always. A shipping label is automatically printed and applied to the side of the carton, containing essential routing information and barcodes. Heavy-duty conveyor belts transport the sealed cartons to the palletizing station, where high-payload robotic arms take over the operation now. The heavy robotic arm stacks the cartons onto a wooden pallet in a precise, interlocking pattern to ensure maximum stability here. Once the pallet is fully loaded, an automated turntable wraps the entire stack in multiple layers of protective stretch film now. Autonomous mobile robots slide underneath the heavy loaded pallet, lifting and transporting it to the warehouse storage area safely now. The smart warehouse features massive automated storage and retrieval systems, organizing thousands of pallets with incredible precision and speed here. When an order is received, the automated system retrieves the correct pallet and routes it instantly to the shipping dock. Forklifts operated by highly precise automated guidance systems safely load the wrapped pallets onto the waiting delivery trucks there now. The delivery trucks depart from the factory gates, carrying the newly minted high-tech devices to global retail markets worldwide now. Every step of this magnificent process highlights the ultimate triumph of modern automation, converting raw elements into everyday marvels here. This perfect harmony of machinery and programming shows how technology shapes the future of manufacturing on a massive global scale. Thank you for watching Mass Production Marvels, and please subscribe for more fascinating insights into the world of industrial automation today.